Hello. The other important thing that we must talk about is the feedback loop in machine learning models. And there are really, why would you want to have feedback in machine learning model? And there are many answers to this question. The first one being to measure if your model is actually performing what it is supposed to do and what is the impact of this model that is happening. And number two is because machine learning models tend to change the behavior of their users in a certain way, and it's very important to understand what these changes could lead to, and having a good awareness and understanding of these factors help us build better machine learning models. So the first feedback is a very direct feedback that is the most simplest to observe. For example, if you are building a recommendation system and a user is engaging with those recommended content, like they, for example, click on a particular content, and once they click on a content, they spend about let's say 80 to 90% time of the entire content, or they can just choose to watch only 10% of the content and drop away. So these kind of metrics will help you understand if the user is engaging more with the recommended content, or is engaging less with the content, and it's a very direct feedback that you get. Now what happens is that typically machine learning algorithms are optimized for one purpose, and typically these purpose, again in case of a recommendation engine, is to engage the user more and more with the kind of content that they are watching, right? So your algorithm could figure out that, hey, this set of user likes to watch this particular content, and they can keep reinforcing and sending that same content to the user again and again, and the user will is definitely going to consume that content and be more engaged with that content. And what it leads to is something called as echo chambers, wherein people change their viewpoint of the world and the society, or about a particular topic, based on that particular content they are watching, because they keep watching the same content over and over again. And this is something that can have very serious implications in practical use cases. There was a very famous case about YouTube promoting pedophile content to a certain segment of users, and because they were watching that content, YouTube was recommending the same content over and over again with more aggression. And what happens is that once users are deep into their echo chambers, they don't even care about for example, marking or reporting that content as bad or offensive. And those kind of signals become diminishing when people are in their echo chamber. So it's very important to be aware of the changes that your machine learning algorithms could bring in real world. The other such example is which is more difficult to predict, is called a hidden feedback loop. So what happens is, for example, if you deploy a machine learning model that is going to predict which areas of the city have more crimes, then what is going to happen is that you are going to deploy more police officers to those areas, and more number of cops on the street will impact in the police organization watching more number of crimes happening. So more crimes are reported from the area where patrol is more, right? And this is also some kind of a filter bubble or a hidden loop, because now you are focusing on specific areas and more crimes are coming, and the model takes this data and learns from it, and it further becomes aggressive in suggesting those areas as the areas wherein a crime could happen. So this is also an example of a far-fetched hidden loop that happens during the deployment of certain machine learning models. And the other thing that is somewhat related to this whole theme is around the biases in the models that we create. And as an example, we can see that there are certain models that are trained on certain kinds of data set, and if your data set isn't a true representation of what is happening, then your machine learning model is going to be biased towards a certain, for example, ethnicity, or for a particular gender or location. Regardless of what attribute it is biasing on, there will always be some bias. And a very classical example was the case of this algorithm that was used to predict if a particular person has a chance of committing a certain crime or not. And this algorithm was specifically trained on certain data, and that data was biased towards the African American population, and they were always shown a high chance of high risk individuals, even if the fact was not really the same. Like there was no role of ethnicity in the crime that they are committing. So these are some very classical examples of biases in models, and as data scientists, as engineers, and as builders of tomorrow, we should be very aware of the of every impact that our machine learning model is going to have on the human life and society, and take care to make sure that the model is as justified, or as equal as possible, without any particular biases in them. Thank you.